myself, Ashish Pandit. I'm senior BIM engineer. So let me first start BIM. As earlier, you have already listened that what is BIM. BIM stands for Building Information Modeling, and to whom this BIM will be helpful to you. First of all, I want to throw the light on that portion so that you can have the clear idea. So if you are CAD manager or CAD engineer or CAD designer or draftsman and you want to transit your career from CAD to BIM, right? So this is the perfect course for you. The project owners, because current as of current date, each and every owners wants their projects in a live 3D model base with technical and parametric based information, so that before the structure has been constructed, each and every error must be rectified and resolved before it will be comes to the practical approach, so that it will be save the cost, save the time, and we will see what are the benefits of the BIM and everyone. So all the architects, engineers, and all the colleagues who are uh, connected to the construction management related industry. So for that, this BIM is very helpful to them. Now, what is the BIM? BIM stands for Building Information Modeling. And building information modeling is nothing but it is the process. BIM is not the software, but BIM is the process. And in the process, starting from the conceptualizing to the project to the final level of delivery of that project to the customer, whatever the different phases are coming, all of the phases, if we are covered up and clubbed to a one process, that process is called as a building information modeling. And BIM is an intelligent model based process. This is very most important. Intelligent model based process. Intelligent model based process means what? From the model, you will be get the technical information, right? Suppose if I have one BIM model and if I will be share that BIM model to the client or contractor or to the fabricator or to anyone, from that model, he or she can get the information. What is the technical information related to that wall, doors, windows from the architecture point of view, beam, column, slab from the structure point of view, duct, pipe, cable tray, wiring from the MEP point of view, and also and from the fabrication point of view also we can get the information. Now, according to the different standards, so AIA, American Institute of Architects, defines BIM as a model-based technology linked with a database of project information. So this is the one definition. If you just do the Google of BIM definition, lot many definitions you will be get based on the country base, based on the standard base, right? So this is the one common definition which I have captured. And BIM is the parametric 3D model based process to generate the plans, sections, elevations, schedules, and all of the necessary information which are to be required in order to construct the building to the reality. So this is the history of the BIM. What is the BIM? So first BIM was conceptualized by the Douglas and in the year of 1962. And at that time, initial phase, it was an CAD, on the CAD base, let's say computer aided design. And later on, it has been transferred to the name BDS, Building Descriptive System, in which paper based all of the information transferred to the prototype. And further, if we will be see in the year of 1982, ArchiCAD was developed as the first BIM software. And later on, day by day, many softwares has been built up. And ArchiCAD 2000 was ArchiCAD was also developed as a BIM software. And later on, they have been renamed as a Autodesk Revit in the year of 2000. Now, BIM adoption. So Right now, many countries are moving forward to the BIM-based process, and they are transferring their day-to-day workflow from CAD-based process to the BIM-based process. So many countries have fully adopted the BIM, and in the foreign base, if we will see, let's say USA, UK, or any other, even though yeah, lot many consultancy are using the fully beam based model approach process, so that rework and time can be saved, and rework efforts will be also going to be saved. This is the evolution of the B. So first, as I have mentioned, initial it was BDS, and thereafter certain process has been evolved by year, decade by decade, 1970 to 1980, 1980 to 1990, 1990 to 2000. In the 2000, professional beam-based process has been start evaluated, and currently nowadays, lot many softwares are day by day increasing in the beam based process, and integration of all of these softwares are also playing a very much powerful role, right? So we will also see what is the integration between the beam based software. So what are the different phases used in the beam based process? So obviously, if we will construct a one project, if we will be think about the one project, so one project, there are not many stages are there, right? So initially we will do the planning, and in the planning, with the help of the client, we will be understanding the requirement of the client, and we will be finalize our planning in terms of space planning, right? Let's say if we will talk about the commercial hospital project or commercial hotel project, so we will be understand the requirement of the client, and find out the total area, and on the basis of that we will be do the conceptualized planning. And once the planning has been approved from the client side, then those planning will be goes to the design base, like structural design, MEP design, as well as also fabrication, and all of the design based approach will be uh, adopt in that project. Then after, from the construction point of view, we have to think about that, like once the all of the IFC means issue for construction, or GFC, good for construction. So once all the IFC and GFC drawings has been received by the consultancy firm, then contractor or client will be start working or construction on actual real site. And once the during the construction, various operation phases we have to comes up, like various many operation phases will be there. And once the project has been completed, then we also have to think about the sustainability point of view. If I want to furthermore depth explore what is the process of BIM. So this is the process. So as I have told, first it will be start from the design. So in the design, conceptual design will be there. Then after, detailed design will be there. Analysis will be there with the help of BIM based software like StatPro, robot structure analysis, tabs, lot many BIM based analysis or designing softwares are there. Then after, documentation to generate the drawings, document, schedules. Then after, fabrication models, we will be also able to generate from the beam-based process by using the Tekla structure softwares for the steel fabrication. Then after, using the construction 4D and 5D simulation based approach that we have to follow up, like using the software of Navisworks or Primavera. So construction logistics, so different we can say transportation and all of the equipment, material transportation, so related transportation, all of the things will be that comes under the construction logistics. And operation, maintenance, renovation, once the building has been constructed, after a certain period of time we have to do the renovation. So this cycle will be completely goes on, and any structure or any project has been constructed, that is constructed for the certain period of year. So again, the designing or validation portion will be also comes in pictures. So next thing is, what are the various, just a minute, what are the various phases that comes or various dimensions that comes in the BIM? As we know, 2D is simple CAD based process or drawing based process. 3D is the model based process. So in the 3D, we will be create a three-dimensional model with intellectual or parametric detail based information, so that from that model we can able to get the information. Then 4D is the time schedule. So time schedule is nothing but we will be manage the time schedule. Okay, so let's say if we are talking about one activity, let's say excavation, and per day this much amount, let's say X amount of excavation has been carried out on the site, and total quantity of excavation that we want to have Y amount. So Y divided by X. So that one will be shows us the total number of days will be required in order to perform that activity. So that is the 4D based process. 5D like cost based process. So we will be adding the cost. Then 6D, that is sustainability, and 7D, that is facility management. So these are the various dimension or various processes, including the BIM. So let me just throw light on various phases of this BIM. So 3D is nothing but the intelligent parametric based model information or parametric based model process. And with the help of Revit, you can create such type of 3D model very easily with understanding of proper tools and technical competency. Then 4D is nothing but construction sequencing. So once the model has been created in the Revit, you can export the Revit model from the Revit in the format of IFC, Industry Foundation Class, and in the Navisworks software, you can import that IFC file, or you can directly import the .rvt Revit native file as well. And in the Navisworks, you will be able to create the 4D construction sequencing process, like what is my start date, end date, plan start, plan end date, and everything you can manage at here. Then 5D, as I have mentioned earlier, 5D is nothing but the cost-based process. So as Revit is a technical parametric based intelligent software. So from the Revit itself, if we will do the modeling correctly, we can find out the quantities from the Revit as well. We can also find out the area, volume, and each and a lot many things are there, and lot many custom quantities we can also able to extract from the Revit itself. Then after, this is about the sustainability. So in terms of the analysis point of view, let's say solar analysis. So what is the performance of the green energy? So in terms of that, we can use the 6D, that is sustainability point of view, and 7D, that is project life cycle information. So that one have much more in-depth information, that facility management, right? Then after operation management. So once the project has been constructed, built, and after certain number of years, or after certain, sorry, sorry, excuse me, a certain number of years, what should be the maintenance process that we need to carry out in that project? So that comes under the 7D process, that is project life cycle information. So this one all about the introduction about the various phases of the beam, right? Now, LOD, you might have heard the word of LOD, LOD, level of detail, level of development. Let's say client wants the LOD 300 model, LOD 350 model, LOD 400 model, LOD 500 model. So what is that exactly LOD? LOD is nothing but level of detail or level of development. So the model which you are producing for the client, for the customer, in which what level of detailing of information that you are going to specify, that comes under the process of the LOD. Let me explain you this one slide with the help of one uh, example. So here you can see we have a one equipment. Let's say for example, and if I will be just showing that equipment with length, width and height, depth and dimension, that comes under the LOD 100, in which we are just occupying the space. Nothing we are going to show them, right? We are just occupying the space, that this is my this is the thing, that this much amount of space is occupied in this model with this equipment. In the LOD 200, we are adding some details, we are adding some information. So approximate geometry, we are adding some information. In the LOD 300, precise geometry or precise information we are adding in terms of quantity, size, shape, location, orientation, right? This is also non-graphic information. We can also attach to the model, right? Non-graphic information means just for the represent point of view, not the actual 3D model. Now in the LOD 400, that is a fabrication based model, right? So LOD 400 model is fabrication. So this is a more specific system, accurate in terms of quantity, shape, size, location, detailing, fabrication, assembly, installation, and installation information. So related to the fabrication construction point of view of any steel structure, what are the information required to the client? So from that information or from that drawing, the client can be able to fabricate the model. So all of that information which we are providing in the model as well as in the drawing, that is comes under the LOD 400. And this one last is the LOD 500, that is as-built construction model. So this is the field verified representation accurate model in terms of shape, size, location, quantity, and orientation, right? So this is the one most important concept you might have been come across hearing this word LOD 400, LOD 450, LOD 4, LOD 350, LOD 300, LOD 500, like that. And obviously in, in our training, we will be covered as built model, so that actual site model based process we will be going through. Now here, these are some logic and valid reasons why we have to use the BIM, right? So BIM is a single 3D database process, and real-time changes can be made by the designers. So a designer who is working on the project have must have the knowledge of all of this BIM-based process softwares like Revit, Navisworks, Primavera, Synchro 4D, and other softwares mentioned in this course list, so that it he or she can be able to interact the real-time changes in by interacting or integrating your current model with the help of using the all of the different softwares. And conflict can be easily dealt with the help of using the beam based process, and they can be easily identified before it can be happening on the site, actual site. And it will be also added you advantage in terms of budget as well as schedule or time. It will be also help you to gain the better coordination between the client, designers, contractors, project managers. So everyone's are working on the same beam based process, so that whatever the changes happen by the client, let's say client needs some comment, we want to add or remove some area, let's say we want to add one room, and on the basis of that architecture will be do some planning, some do the addition alteration in the existing planning. That addition alteration changes will be gone through a structural discipline or structural fellow. That same discipline, same changes will be gone through the MEP fellow, right? So like that, each and every colleagues who are working in this project are on the same platform. So it will be help to better coordinate between the people, between the colleagues, and in order to avoid conflict or miscommunication, right? So that is also one major advantage of using the BIM. Now, with the help of the BIM, we can obviously increase our efficiency, increase the collaboration, and we can also able to increase the communication. Now, how in communication in terms of how you can increase, let's say you have received the 3D model and you are commenting on that 3D model so that your comments are also going to be stored. And let's say after certain period of time, let's say after 3 months, 4 months, or 1 year or 1.5 year, if anyone want to track what are the comment or suggestions has been given by the client or given by the architect or given by the engineer, so all of the records can be easily tracked with the help of this BIM process. And obviously, it will be also help us to decrease the time which actually required in order to complete that project. Then cost, it will be also help to reduce the cost, because obviously if error or mistakes which are actually happening on the site, if it will be rectified before it will be play actually onto the site, then obviously our cost will be also going to be play a vital role, and it will be also decrease. And conflict between the contractor, client, owner, and engineers, architect, that conflict can be also decreases by applying application of the beam based process. Because we have seen in my professional career, I have seen that the consultancy firm who are using the beam process based software, it will be very easy to them as well, and it will be very easy to us as well, to have the better communicate, better clear idea that exactly what is the requirement and how it will be going through better clash detection, clash checking, right? But in terms of 2D, what happens, everything we have to do the manually based process, and it will be required lot of efforts, and it will be also required lot of technical competency. So that one, all of that rework and all that things can be uh, reduced by applying the process of this BIM. And these are some advantages of the BIM. It will be improve the visualization. It will be have a more fast and more efficient process, because you are very clear from the day one that this is the our model, and whatever the changes that we want to do, we can make some mark or making some tags or making some notes, and we are able to track all of that changes. So it will be easy for the efficient and fast process, because currently as of now, all of we know that construction cost plays a very vital role, right? So if we will apply some amount of money in the BIM process based software, then that construction cost will be far reduced, and it will be also able to have the complete the project within the time budget. So that is also the advantage of the BIM. Better services to the client, obviously we can offer the better services, more reliable models produced to the client, so that client will be also have the clear idea actually before it will be actually happen on the site. Improve the productivity, quality, increase the speed of delivery, okay, with the help of reducing the rework or like a drafting error. So all of that things are neglect by process of application of the BIM. So our speed of delivery will be also increase, reduce the cost on the both end, from the design end as well from the construction end. So on the both end, cost will be reduced and increase the coordination between the construction documentation, right? And these are also elimination in budget changes up to 40%, precision cost estimation up to 3%. So obviously with the help of the BIM, you are able to track the 5D cost analysis with the help of the BIM process. So you can easily compare your project budget cost and actual cost, so that it can be easily tracked where is the mistake and where we are lacking, and why the cost is increased, or what is the reason behind that, or whatever the thing. So it can be easily tracked. Decrease up to 80% of the time needed, that is generation of expenditure quotes, and it will be help us to save the time in terms of giving the uh, value-based addition to the client, like clash detection, right? So let's say if we are talking about one model in which architecture discipline is there, structure discipline is there, MEP discipline is there, and in that model, obviously, lot money services plays a vital role. So in the BIM, if we are able to do the exact modeling an exact drawing, an exact scheduling from in the BIM Revit based software, so that it can be easily tracked in the software. Where is actually the clash is there? What is the clash? Whether this clash is allowable, whether this clash is within the tolerance limit or not. If we want to avoid this clash, then what are the precautions we need to take care? So all of the things can be taken or will be taken care in the software BIM based process itself, and it will be help us to saving the time up to the 7%. And as we know, there are lot many softwares are comes into the play in the BIM process base. So first one is the obviously very useful and widely helpful, that is Autodesk Revit. In the Revit, there are three disciplines are there: architectural, structural, MEP, mechanical, electrical, plumbing. In the MEP, firefighting system will be also comes into the picture, and the sprinkler system also comes into the picture. Undergrounding pipe will be also comes into the picture. Let's say we are not talking about the only commercial building. Let's say we are talking about the industrial building, or let's say industrial plants. So in the industrial plants, what is happening? You have a one surface, and below that ground level surface, there are lot many utilities are running, right? Cable duct is running, pipe is running, right? Trench is running, right? Because to drain of the surface water, so trenches are running, like we can say clean water system is there. Then after if some oil based process is there, then the contamination oil removal process system will be there. So lot many, let's say from substructure, or let's say below the ground level, and on the superstructure also, lot many disciplines comes into the picture. So let's say non-process building is there, process buildings are there. Let's say steel fabrication is there, pipe rack is there, pipe rack module is there. So in that discipline, in that aspect, this Revit plays a very vital role, because Revit is the one and only one software which can be able to do the model in, in architecture base, in structure base, and in the MEP base. So within the software, you can able to track each and every possible changes, errors, class detection, and everything. You can easily able to get the tracking within the Revit software. So not only in industrial industry, or not only in the construction industry. If we are talking about the GIS base, okay, geographical information system, in which also Revit plays also very vital role. Let's say we have a one surface, one land, right? And let's say that is the existing surface or existing land, and we want to have a proposed surface, and in which we want to prepare a proposed surface in such a way that our excavation cut and fill quantity can be balanced. So whatever the amount of excavation which I will be taken care, or which I will be taking out from the site, same amount of excavation can be also helpful in the filling as well. So that no the additional amount of soil which I want to borrow from the other area, in order to have reduce the transportation cost. So in that point of view, also Revit plays a very vital role. And during our this training, I will show you in the Revit architecture that how we can able to generate the topo surface with the help of existing surface, proposed surface, finding out the quantities, net cut fill quantity, finding out the elevation level, so that it will be helpful to us in actual process based software. Then obviously Bluebeam is also the one software which is also play a very vital role, the beam based process based software, because in the Bluebeam, whatever the thing which I have explained you earlier, like tracking the changes, right? Let's say today I have generated a one document, and in that document I am making one comment. So all of that comments are traced or are recorded, right? And at the end of the project, we can able to track all the records, and we can able to get the things. Then synchronize 4D, then after Primavera Professional, then after Microsoft Project, in Building Studio, Tekla Structure, Start Pro. So lot many things. If you just do the Google Beam process based software, you will get much more list, because currently each and every software they want to try to build up as a Beam based software in the civil industry, so that it can be easily integrate with the other discipline. Now let me take a 1 or 2 minutes in order to explain what is the interoperability, because we have practically worked on this process, so that I want to throw a light on that process. Let's say I'm the expert of the Revit, Autodesk Revit, right? I have the expertise knowledge of Autodesk Revit architecture and Revit structure. And now client have given me a one project. So what I will be suggest to the client, I will be do the architecture, structure and MEP modeling in Autodesk Revit. Now the other colleague who is working in the same project, he or she doesn't have the knowledge of the Revit, but he or she has the knowledge of the Navisworks managed, say for example. So Revit software can produce any BIM process based software. Let's say 3D model based software. Let's say Revit or Tekla. We can say these two examples that can be able to produce the IFC file level. If you have heard about the 2D based process, so DWG, DGN, okay, DF, DWF, DXF, these are the common file format used in 2D based process. So similarly, in 3D BIM based process, IFC file is the common file format which is used. So from the Revit, I can able to extract the IFC file format from the Revit, and that IFC file can be easily imported into the Navisworks software, in the Tekla software. Let's say in the Tekla of the same building project of the steel structure I'm doing in Tekla structure, let's say, so that I can easily correlate or easily integrate my Revit IFC file into a Tekla. So whatever the, if I will be update that IFC file, the same each and every changes are also reflected to the Tekla software as well. Now let me do the vice versa. Let's say if somebody has did the modeling in Tekla structures and we want to bring that model in Revit in terms of IFC, so we can also able to import or link that IFC file. So let's say after a certain period of time, let's say after 2 days or 3 days, client or designer made some changes in that IFC file. So if we will be reload that process or reload that model, so all of the changes which did in Tekla structure software can be easily traced in the Autodesk Revit software as well. So this is the one complete information related to the BIM. So these are all of the softwares comes a very vital comes into the picture of the BIM process base, and it plays a very vital role uh, in order to complete the BIM process. So that's the end of my presentation, and let me have a quick overview about the projects in the Autodesk Revit architecture and as well and Autodesk Revit structure. And at the last, I will be handle the quick Q&A, question and answer, if the any users have, right? So I have shared my Autodesk Revit screen. So this is the Revit software in which I will be starting first of all with a very common and a very simple project in which you will be able to understand each and every command which are used in the Revit architecture, because Revit is the software which is the process based software. This is not command based software, right? So you have to understand the process. So let's say how the footing will be there, wall footing, column footing, isolated footing, right? Then after in terms of walls, so insulated wall, firefighting wall, right? Brick wall, RCC wall, right? Then after in terms of doors, windows, lot many things are there. In the doors, windows, component, column, roof. So by first, I will be show you this project, and with the help of this project, you will be able to understand it how to use the Autodesk Revit software, because Revit software is not like as an AutoCAD software. Let's say if you understand or learn 50 command or 60 command, then you can create any kind of drawing in the AutoCAD. That's not the thing which is happening at here. So the participant who have joined in this meeting, I hope that they have the knowledge of AutoCAD. So they will be easily correlate with this my statement that if he or she has the knowledge of 50 or 60 common use command, then easily it can be traced or create any kind of drawings, right? So similarly, next thing is related to the technical base. So in the technical base, what is happening? So how to create the floors, railing, columns, roof, then after slab, then after doors, windows. Okay, so this is the one common project or simple project we can say, and with the help of this project, you will be able to understand everything, each and every command which are available in the architecture panel. Okay, this is my Revit screen and this is my architecture panel of this Revit screen. Okay, so wall, door, window, component, column, row, floor, and so on, right? And we will be also able to extract the views as well. Views as well in the terms of we can say plan views. Okay, we will be also able to extract the schedules, then after sections, elevations, and placing all of these things into the sheets so that it will be have the proper information of plan, elevation, section, floor wise. Okay, if we are talking about a one project, so let's say I have one project, let's say 50-story building. So in the CAD process, what we are doing, we are creating separate file for the architecture, separate file for the structure, separate file for the MEP. But here we can do the modeling of architecture in one file, structural modeling, then link the architecture file into the structure, and then after link architecture and structure file into the MEP template, and we will be able to model the docks, pipes, routes, and everything, right? So such kind of sheets, views, schedules, we can be easily able to extract with help of this project. So this is the one very simple project from which our journey will be start, and later on I will be going through you some advanced level of project. This is which I can say some advanced. Here you can see my topography is very, or terrain or surface is slanted, right? Roads are there, plants are there, roof systems is there, wall system is there. This is not simple wall. If I will be selecting this wall, going to edit type and going to structure edit, here you will be able to see lot many layers are there, and I will be explain you what are those layers and why such kind of information we will be required. Okay, how we can assign different materials to the different layers. So lot many things we will be covered up during our live training. Then after, some curtain walls are also there. So as you can see, some curtain walls or glass walls are there, right? Staircase is there, handrail is there. Then after footing, then after we can say lot many things are there. Here, if I will be show you sheet view, right? So lot many sheets are also there. So here some views have been created like first floor plan view, then after basement plan view, and we can create the working drawing. Working drawing in terms of, as you can see, such kind of giving all the dimensions into the drawing, assigning the proper scale, assigning the room names. Then after we can also able to extract the colorful legend. So if I will be going to annotate tab and generate the color fill schedules. So just clicking at here, rooms and names. So we can also able to extract the color fill schedules. So which color represent which rooms, and we can also able to change the color and so on, right? So such kind of color fill schedules or view plan views we can able to extract it from the Revit. Then after 3D views or camera views, we can able to extract from the Revit. We can give these camera views to place these camera views into the sheet as well for the better understanding to the client, and extract the PDFs drawings from that sheets, right? Then after we can have the schedules or drafting views, or we can say legend views. Legend views in the terms of, let's say this is my one door. Okay, so which type of door is there? What is the plan dimensions of that door? What is the elevation dimension of that door? What is the mark used in that door? So such kind of information we can also able to extract from this uh, Revit software as well, right? So such type of advanced level of technical skills we will be also able to do during our live session, during our live training session. Then after, let me throw a one light into the custom staircase modeling. Now let's say if I want to talk about only the staircase base. So in the staircase base, as you can see, I have different material on riser, different material on trade. I can create the nosing. As you can see, my railing profile is also different. So I can create custom railing profile like different baluster, different posts, different spindles, right? So such type of custom staircase, if we want to create it, we can also able to create with the help of Autodesk Revit. Then after, let's say we want to, just a minute. Yeah. Yeah. And then after, let's say if we want to extract the detailed drawings, right? Let's say we did the modeling. We want to extract the detailed drawings from the model. So such type of detailed drawing we can also able to extract. Let's say this is my brick layer is there. Here is the interior finished level is there. This is CMU. CMU means concrete masonry unit. This is my flashing is there. Here is the floor finish. Here is the rebar. Here is the earth. Here is the PCC, right? Then after we have the rebar, we can also model the rebar, and we can also able to extract the bar bending schedules from the Revit, because in the Revit we will do the modeling of rebar as well as extracting the bar bending schedule. So such type of detailing uh, presentation we can also able to extract from the Revit, because here you can see nothing is manual, everything is automatic. So if I will be select this wall, as you can see, this wall is nothing but exterior brick and CMU concrete masonry unit on MTL metal stud. So in the US based process, studs are used, right? And in the studs, various processes, or we can say various layers are there. Thermal air insulation layer is there, right? Structure layer is there. So as you can see, this is metal stud layer that is 6 inch. And on the one side, exterior side, these are the layers are there. Interior side, gypsum wall board is there. Vapor retarder is there. So such type of a detailed wall, which is exactly happening on the side. We are not just creating a wall that what the client have asked for, but we are providing that material base, or we can say intelligent parametric base model. So from that model, client can be able to extract the quantities as well. Let's say now if I have model, I did model of this wall, and if client asks me, tell me the quantity of the CMU metal stud, of how many studs are there, what is the quantity of the plastering, and each and every material quantity can be easily uh, trace or can be easily extract from this model, right? But how it will be possible? Whenever you did such type of detailed level of modeling, then and then it will be able to possible it, right? Now let me show you some lights on the Revit structure as well. So if I will be going to use, so there are lot many projects are there in architecture. This is not the only this type of project. This type of project we will be learning, or we will be I will be show you creating such kind of models in our live session or live training. And with the help of creating such type of project, you will be able to create any kind of in-depth multi-story architectural buildings as well, right? But understanding of technical competency and understanding the process, that is the most important thing which I have seen in my entire career journey, professional career journey. That understanding the process is very much important rather than just creating the model, right? So process understanding is very most important. So I will be explaining you each and everything very detailed, start from the scratch level up to the end level, so that you can have the complete idea. If you are going to start a new project in Revit architecture, what are the things that you need to do? Start from zero level to, you want to deliver a project to the IFC level, or issue for construction, or working plan, or GFC level, or good for construction. So, or let's say submit level, issued for permit, IFP in the US based system. You might have come the word of IFP, issue for permit, right? So such type of drawings, how you will be able to extract from the Revit, each and every process you will be able to understand it very clearly. Now, Let me talk about the structure point of view. So from the structure point of view, as we know, there are major two things, right? One is the steel and one is the RCC. Okay. So in the steel, what is happening? Revit obviously do the accurate modeling of the steel structures in which we can do such type of connections, then after beams, columns, then after footings, anchor bolt, gazette plate, right? Then after we can have the bracings, okay, bracings in the plants, bracing in the elevation, because sometimes we also need to provide the bracing in the roof as well, right? That depends on the structures. So we will be creating such type of advanced level of totally fabrication based steel structure modeling, in which you will be completely understand the process how to do the structural modeling of such type of project. And here you can see each and every connections are not a standard connection which are comes with installation of Revit. Here you can see this is the one connection which I have, which is the custom connection. As you can see, this is not the connection one. This is not the one connection that is comes with the standard Revit installation. So such type of custom connection, if you want to create, then how to create such type of custom connection, that process we will be also able to see in our live training session, so that you can have the complete idea of how to do the fabrication modeling of such type of steel structure process. So here you can see, if I will be show you the sheet view. So in the sheet view, you can see we have created the plants. Just a minute, it is reloading. Actually, in the sheets, views are there, some 3D views, working, taggings, okay, detail level of drawings are there. So that's why it requires some amount of graphic process in order to execute it. And obviously, we will conduct the training in latest software of Revit, so that you can have the complete idea with the latest tools, techniques, and command-based process, right? So as you can see, this is the one level one view. Here you can see each and every bracings are tagged, the dimensions are there, right? Then after putting columns, then after we can say beams, right? In the above level, you can see the beams are also there. So beams are also there. Then after you can see some elevations or sections have been also extracted. Each and every level of information, like zero level, then after level at 4 meter, level at 8 meter, right? And if you want to extract some let's say assembly view in the terms of what? Assembly view means, let's say you want to explore some process, let's say in the footing, how my anchor bolts are fixed, how my gusset plate will be fixed. So as you can see, such type of exploded view, or we can say assembly view, we can also able to extract within the Revit itself. And here we can set sorry, here we can set the visibility of this pad footing as well. Let's say which type of anchor bolts we are using, column, gusset plate, base plate, right? Then after we can have the enlarged detail of this, because this is the thing that fabricator required, right? Because fabricator want to have the base plate or gusset plate detail. Then how such type of detail can be able to extract it? So like that way we can able to extract it. So this is the one steel structure project. Now if we will see architecture base, RCC base. So the RCC base, obviously beam, RCC beams, columns, footings, plinth beam, ground beam, slab beam, right? Then after ground level slab, plinth level slab, I have just shown you one or two story building. That is more than enough. to learn the process, to learn the workflow, that is more than enough, right? Because you are come here to learn the process, to learn the concepts, to learn the technical competency. But and same thing, let's say same thing is repeated for the technical floors. You can also do the copy paste. So it's not a rocket science. But the important thing is you have to understand each and every process and how to do the. Here you can see I did the reinforcement modeling in one floor only, right? So in one floor, we did the reinforcement modeling of slab, beam, column, footing, and these are the views. Now here you might be wondering why views have blue color icon, white color icon, right? Because the views which are already placed in the sheets, as per the latest re- new features onwards 2023, that views which are placed on the sheets have been identified with the blue color so that you can have idea that this is the one view which is placed anywhere on the sheet, and the views which are only the white color space are not placed on the sheet. So as you can see, some schedules are also there, right? Bar bending schedule of ground floor beam, then after first floor slab, first floor column. So one complete workflow we will be see in the process so that you can have the complete idea. Now, let me show you all of this thing into the PDF drawing so that it will be easy for us to understand it. As you can see, this is the one PDF which is extracted from that project. So here you can see this is the grid location and column location. And here you can see the marking of the column, that's a tagging of the column C1, C2, C3, or distance of that column, right? Then after we can also able to generate the schedule of that column. C1, what is the size, right? What is the volume of that column, right? How many number of C1 are there? This is all we can say automated base. We do not have to do any manual process, and this is the thing actually exactly client wants, because later on if any change happen in the model, we do not have to worry about in scheduling in the drawing based process, right? Everything should be automatic so that then it will be have the proper advantage of doing the 3D parametric based modeling. Here you can see we have the curved beam as well, so we have created the curve grid as well, right? And how to identify and locate that curve grid. So as we can see, this is the one intersection. Let's say, for example, intersection H7. So if from the H7, if we will go towards west side, 1380 mm, and towards the south side from that intersection, 1380 mm. This is the center of that grid, and this is the radius of that grid, so that on the side that grid can be easily plot, right? So this is the one drawing. Then after is you can see here footings also comes into the picture, F1, F2, right? Then after grids, some detailed views of that footings are also there. Let's say F1, 24 numbers are there. This is a length, width, thickness. Then after volume, this is the F2 tag is there. 5 numbers are there. That's a length, width, thickness, volume, and so on, right? So how to create such type of automatic schedule from the Revit, that I will show you during our live training session. Then after this is the one which is the time beam plan view, right? So this is the time beam. Obviously, you can also mention the elevation here as well. Let's say time beam at this level, okay? So that the client can be easily, or any person who is reading this drawing can be easily trace that from which level this plan has been cut. And here, as you can see, tie beam, all of the tie beam has been given the proper numbering, sequencing, dimensions, right? Grid to grid dimension, space, everything. For related structural modeling, this is the complete project, we can say, in which all the terminologies will be comes into the picture, like how to do the modeling of straight elements of beams, then curved element of the beam, then after column, slab, footing, staircase, right? Then after this is the ground floor slab level. So in the ground floor slab level, this is the formwork drawing, right? So in the ground floor slab level in the formwork drawing, what are the dimensions? needs to be required in order to execute this floor slab, ground floor slab onto the site. So each and everything is mentioned at here. Here it will be also mentioned with some schedules, right? Ground floor beam schedules, ground floor slab schedules, like that. Then after, if we will see, this is first floor slab. This is the typical floors, we can say. So first floor slab is there, and then after parapet beams are there. These are some 3D views which have been extracted from the model. So as you can see, 3D view one at this level below the ground floor slab. So as you can see, so we can easily trace, right? Then after, this is the another 3D view in which suction box, or we can say view range, has been extended. So this is the complete 3D model or complete 3D view. Then after, we can have the sections. Okay, in the sections we can have the complete information. What is the level of the foundation? The level of the foundation is minus 500 mm. Then after, tie beams at 0 level. Then after, ground floor slab is 3600 level. Then after, landing of the staircase is 2 meter, right? Elevation. This is a spot elevation symbol. So this is the elevation, and each and everything you can link it up, right? Then after, this is another section which is extracted from this project. Then after, some detailed views, let's say foundation plan view. So in the foundation plan view, this is the reinforcement detail of the foundation plan. We can model the foundation plan like horizontally, vertically, right? And we can tag the reinforcement. Then after, we can extract such type of BBS, bar bending schedule. So 16 diameter of bar, 6 number of quantity. What is the length of B? What is the length of C? What is the length of D? Then after, weight of that rebar, weight of one foundation. Okay, so if we have the total 24 foundation, so 24 multiplied by this amount, then it will be gives you some
Hello.
number. Yes. Then after, we will be able to extract such kind of tie beams. Then after, tie beams of in the ground floor ground beam. Then after, in the plinth beam, right? Then after, creating such type of schedules. So, and creating these overall schedules, right? Floor slab with the reinforcement detail. This is the reinforcement detail. And by using this reinforcement detail on the side, the reinforcement will be able to extract it. So such type of reinforcement detail drawing, how to create that one also I will be show you in our live training. And this is the top reinforcement detail, top reinforcement detail of the ground floor slab, bottom reinforcement detail. This is the bottom reinforcement detail. This is the top reinforcement detail, right? Then after, next we will have the staircase, stair rebar. So rebar in the staircase, that is also I will be show you how to do the rebar modeling in the staircase, how to do the drawing presentation, extract the schedules. Okay, and lastly, how to combine all of those views into the sheet, and how to extract such type of combined PDF, so that now this PDF will be helpful us in a very logical manner, and client can mark the comments on this PDF with the help of the Bluebeam software, and can easily trace out. So, and lastly, we also have the Revit Dynamo. So related Dynamo is nothing but the automatic process based system. So if anyone have the knowledge of programming, like say visual programming, right? So it will be do some automated task. Let's say if I want to give the dimension of grade to grade. So by using that or running that script, I can able to give the dimension very easily. So that is the work process. And during our live training session, I will be show you what is the Dynamo process. Actually, it will be helpful in our day-to-day workflow in BIM process-based workflow, right? So yes, I will request to host Roshni ma'am. If anyone have any questions related to my topic, I can address to those questions.
Yeah, thank you so much, sir. Thank you so much for your insightful presentation on BIM. And anyone have any doubts?
Hello.
I
Yes.
think, yeah, that's it. So thank you. We truly appreciate your valuable knowledge and expertise. Thank you so much.
Okay, well, so shall I left?
Uh, okay, yes. Yeah.
Uh, if anyone doesn't have, no one have
Excuse
any.
me, sir.
Hello,
Yes, sir. Yeah,
hello,
yeah,
Okay.
hello.
yeah, yeah.
Excuse me,
Sir,
sir.
can we use Revit instead of SketchUp for interior designing?
Obviously, Revit can be also used in for the interior purpose as well. Because in the interior, what is the thing? You are doing the detailed modeling of, let's say, furniture, right? You are
Yeah.
doing the detailed modeling of the interior wall, doing some designing in the wall. So for that purpose, Revit is also widely used. And during that training, I will also show you the one interior example so that you can also correlate those things with the help of Autodesk Revit. So yes, Revit is widely used for the beam process based exterior as well as in interior, both from both point of view. Yes, we can use it.
Sir, I have used the older version for few months,
Yeah.
but I didn't get some color grading grades, sir.
Actually, to be honestly, Revit is not a rendering based software. To be honestly, I'm telling you very frankly, Revit
Okay.
is process based modeling software. In the SketchUp also, you might have been seeing that you did the modeling in SketchUp, and then after you will be do the rendering in either V-Ray or Lumion or Enscape or Twinmotion, like that. Those are the rendering engines, right? So
Okay.
similarly, in the Revit to Lumion workflow is also there, because as of now, in current our task, what we are doing the modeling in Revit, and then we are exporting our model into the Lumion file format, and then after import that model into the Lumion and doing the applying startup application of material application, then rendering, texturing, walkthrough, and everything. So related to that animation, texturing, rendering point of view, I would suggest that the best option is doing any rendering engine solution, either Lumion or Enscape or Twinmotion or V-Ray, but Revit is not best for that. And because Revit, obviously Autodesk Cloud has some rendering engines as well, but it might takes more time and lot many efforts we have to apply. So it's better to use the any rendering engine solution. But yes, we can do the modeling in Revit and we can export that model into the Lumion, and that one can be helpful to us. And later on, our host will be share you one link in which we did the model Revit, and then after and then after export that model into the Lumion, and how very nice walkthrough and animation can be created. That link also will be share you later on. Yeah.
Okay, sir. Thank you, sir.
Okay. Any other question?
Hello.
Yeah.
Sir, sir, actually, I posted one question in comment box.
Yeah. Yeah. Please. Can anyone read? I cannot be able to see that question.
Okay, sir, I will ask that.
Yeah. Yeah. Sure. Yeah. 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 Please.
In Revit, we are generating that structural detailing drawings.
Okay.
How means in Revit itself, it is doing the structural analysis like ETABS and StatPro. How
No, no,
compare?
no, no. Revit is not a analysis based software.
Okay.
Analysis based software is StatPro, ETABS, and robot structure analysis. But
Yeah.
Revit is process based, or let's say modeling based software. Let's say from the designing, we get some sizes, right? Let's say 350 by 450 mm
Okay.
beam we have to use, and this much is the reinforcement quantity, right? And
That we have to take from ETABS or
from
Stat.
ETABS or from STAIR or from robot
Okay.
structure analysis. And we
Okay.
will do that modeling in Revit and extract the exact BBS. And we will
Okay.
be exact doing the rebar or reinforcement modeling of beam column junction, beam slab junction. So Revit is not the software for the analysis or designing point of view. Revit is the software
And
from
what
the.
about Revit structures, sir? Revit structure is there one.
Yeah, yeah, but that is what I'm showing you right now in my screen. As you can see, I have shown one beam with
Okay.
reinforcement modeling with BBS. That is what Revit structure is. Structure is not it doing analysis. Structure is it
Okay.
doing modeling, right?
Okay. Okay.
Because
Analysis
StatPro
we have to
is
perform in Stat or ETABS only.
yeah, correct. Because
Okay.
in exactly PMC firm, in consultancy firm, what they are doing, they are finding or doing the design instead and verify it with the Excel or any other manual process. And then after They are giving us the correct sizes of the element, and then after reinforcement information they are providing us, and we need to do the model, and we need to extract the publication level of information, such type of information that that can be helpful inside. Yeah.
Okay, 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 okay. Sir. Thank you.
Yeah. Any other question?
Thank you so much, sir, for your time and support. We had a great time learning about the BIM and the Revit. Now we are going up next to our next instructor, Mr. F. Faraz Ahmed, with over 8 years of experience. He is a senior BIM MEP engineer and will be guiding us through Revit MEP. Anish? Okay, right. Over to you, sir.
Hi everyone, thank you Roshni. As you all know, Roshni just introduced me. My name is Faraz, and I am currently working as a BIM lead. And I have 8 years of experience, and I have been teaching pretty much like for past 8 years. I have been teaching Revit, and I am sun certified in MEP. Okay, BIM and MEP. I'll first share my screen. Uh, Let me know if you're able to see the screen.
Yes, sir. You can go ahead.
Yes. Yes. So I hope you all know my name now. Let us continue without much ado. We have very much less time now. My session will be very quick, and I'll be just giving you the introduction about what is BIM and what is MEP and what is Revit, how we can utilize BIM to mitigate the losses and increase the profit within the construction field. Okay, so I believe that all of you are not working professionals. Maybe many of you are new people, very fresh students. I will be targeting you as well. I will start with the basics. Let us first try to understand what is BIM. As our colleague already discussed the process of BIM and all, let me give a quick overview of what exactly the BIM is. Okay, so actually the we might have heard about IT sector and all. Has everyone heard about IT, where we do the programming, Python, this and all, coding,
Yes, sir.
right? Yes. So thank you. Be interactive. The sessions will be interesting. Okay. So what I was saying is, everyone knows what IT is, right? IT, it is a kind of a branch of computer science, that programming, that this and all. Similarly, there is a branch, specific branch for mechanical and civil people. Okay. So that field is called as BIM. Okay, let us first try to understand what exactly BIM is. So BIM is a process. As our colleague stated, the BIM is a process. It is not a software. It is not a tool. It is a process. Okay, BIM is a process. What exactly is that process? Let us imagine our construction. Like everyone might have seen the construction, right? They might have constructed their own homes, or they might be, some people might have worked as a site engineer or something. You might have seen what are the basic components of a construction. Let us assume you are constructing a home. What are the basic things comes into construction? First comes the structure, right? The RCC, columns, pillars, that, this and all. These are the structural aspects of construction. Similarly, after that, what do we have? We have walls, furniture, interiors, right? Painting, the fine. So these are the architectural aspects of construction, actually, architectural aspects of construction. Similarly, there is another thing, mechanical and electrical and plumbing services. Plumbing services, it is available in each and every home, right? Similarly, mechanical services, the one which provides you cool and circulated air condition. You might have heard about centralized AC, ductless AC, duct AC and all. So mechanical aspects of construction are these: ventilation and air conditioning. Okay. Similarly, plumbing aspects, we all know, for our washrooms, kitchen, utility, right? So these are the plumbing related vertical of our construction. And electrical, obviously, lights, switches, fans, and the power to all your Wi-Fi devices, security cameras, right? So these are the electrical verticals of your construction. Fine. MEP is an integral part of construction. Did you guys understand what MEP is? What are the concept? Like you might have gone to a metro station or a bank or something where you can see cold air is coming through a grill or something. No, so that is your mechanical aspect. Okay, so like this, mechanical, electrical, and plumbing, as our colleague already stated, Revit is a tool within BIM. Okay, BIM has so many tools. It is not just Revit. BIM has so many tools. Within that, we are just discussing what Revit is for now in our today's session. Exactly, Hanif, HVAC, heating, ventilation, air conditioning. This is the part of like integral part of mechanical aspect of construction. Okay, so what I was saying is BIM has n number of softwares. Among that, we are discussing only about Revit in today's workshop. Fine. So within that, see, Revit can be used for architectural modeling, structural modeling, and MEP modeling. MEP is, I'll show you what exactly MEP, how it looks and all. Okay, so first let us, this is the theme of our workshop today. BIM, it is a process, it is a field of mechanical and civil people, even electrical people can join within this, they also come under this. Okay, and then it is a process, it has so many softwares, Revit is one among them. Khalas. Okay, this is the theme which we are going to discuss today. Then let us now first focus on what is BIM. See, BIM is a digital representation. Before construction starts at site, what do? We prepare a 3D model of it using BIM process. There are so many processes within BIM, and using those processes, we create a 3D model of our building, including architecture, structure, interior, landscape, and mechanical, electrical, plumbing services. Fine. Now, this digital representation, the one which we prepared within the system before construction started, this digital representation acts as a database. To whom? To the construction workers, to the mechanical people, to electrical people, plumbing people, structural people. They will extract the drawings from our model and they will start constructing at site based on our drawings only. Then what is the benefit of using BIM then? That we will discuss in next slide maybe. So let me first finish the definition of BIM. It is a digital representation of a facility, of a building, basically. That digital representation acts as a database for all the stakeholders. Stakeholders in the sense, mechanical people, electrical people, plumbing people, architecture people, and structure people at site. Okay, so this digital representation acts as a database to all of them when that is very important throughout the building life cycle. What is the life cycle of a building? Can someone explain or tell or define what is the life cycle of a building? How does it start? First, it starts with a concept, right? It starts with a concept. I want to construct a home. It should be 3 BHK. These many toilets should be there. These many washrooms and a hall, kitchen. Here it should be like, this is my imagination. This is called as a concept. Okay, like, understood? I hope you people are understanding. If you have any questions, you can ask me. Okay, so the life cycle of a building starts with a concept. It goes on up to the demolition. In between, we also have construction stage. We have, yes, concept to demolition and recycling. Exactly. That is what I was saying. Concept, then design, then construction, then we have demolition. Even in demolition also, this BIM, this model which we created will come into picture. How? You might have seen videos of buildings getting demolished using dynamites. You might have seen the building gets collapsed there itself. How will they know where to put the dynamite? Sorry, not dynamo, dynamite. How do they know where to put the explosives, which will affect, with the impact should be more, no? They will not simply waste their explosives and all. So based on our digital representation, which we created before that construction started, based on that only they'll understand, they'll do the analysis and they'll understand which are the weakest areas, which are the strong areas, where are we supposed to put our explosives and all. So the BIM is used from the concept till the demolition. And in between, we have construction, we have maintenance also. For maintenance also, for example, let us assume Burj Khalifa. Everyone knows Burj Khalifa, right? How big it is. How to manage that huge building. For that, there is a different process in BIM called as facility management or building management system. Okay, that is also part of BIM. Hi. So what I was saying is, BIM is a digital representation of a facility which serves as a database to all the stakeholders throughout its life cycle, building's life cycle. So building's life, this BIM can be used from concept till demolition, and also managing, facility management. Okay, so these are the processes, and as our colleague already stated, BIM has a number of processes, and the processes are shown here. So basically what we can do, we can plan when our construction will start, how will it start, what are the elements required, how big it will be, how much time frame it will take. Okay, so these are the decision making things at the initial stages. Then comes the construction. Okay, then comes the analysis. What is meant by analysis? To calculate, to see the strength or the performance of that building before construction starts. Okay, we can understand whether this building is suitable, is it strong enough, sturdy enough to withstand these many people and these many elements within that building, and how long will it sustain. Okay, so that is what analysis means. Analysis also, in general terms, I'll explain you what analysis is. For example, there is a building which has 10 number of CCTV cameras. How will you know those cameras are covering all the areas? You have to do the analysis. There might be some dark spots, no, like where the camera is not focusing, the field of view is not proper. How will they do, how will they understand that? For that, there is a process called as analysis. They'll do the CCTV FOV analysis, field of view analysis. Based on that, they will understand which are the areas considered as dark spots, like where the coverage is not focusing and all. And based on that, they will add on another camera. This is what exactly analysis is. Okay, after that we also have maintenance. As I told before, building management system, they do the maintenance using our model itself. How will they know? Like, for example, the Burj Khalifa was constructed long back, and the people who are currently maintaining that property are completely, they might be new. How will they know which element, who made it, which company make it is, what is the material of that particular device or element? Let us assume there is a switch which is now broken. How will they know what company it is, when was it procured, who manufactured it? So based on our model, they will understand from where shall I reorder that particular element. That is what BMS is in general terms. I'm quickly explaining all these things. All these things will be like discussed in detail during our sessions. Okay, so there are so many various processes within BIM. The processes are already been discussed by our colleague. So the basic thing which you have to understand here is BIM is used to create a digital representation of a building. That representation can be used as a database throughout the building's life cycle by all the stakeholders. That is the basic idea of what BIM is. Okay, now why shall we use BIM? Let us compare the conventional methods and the latest methods of construction. In the previous days, they were doing hand sketch drawings and all, right? They were using mini drafter or drafter, and they were drawing so many lines and all. What if client comes tomorrow and says that I want a design change here, I don't want room here, instead I want a room on the right side? How much time it will take for them to do that change within that drawing? Right, it will take like lot of time it will take, and the drawing quality will be not that good. If you erase some lines and all, how will the drawing look, right? But now what we are doing, we are using BIM, where managing the changes is very, very simple. Okay, and also we can check the real-time clashes. There are n number of services, guys. We know only about walls, doors, windows, and all. There might be some false ceiling above that. N number of services are running: pipes, wires, cables, ducts, firefighting pipes, fire protection pipes. The n number of services are running above the false ceiling, and they might be clashing with each other within the drawing, right? I am comparing the conventional method and latest methods. In the 2D method, while we were drawing using drafter and all, how will they know that whether the services are clashing with it or not? Everyone was drawing from the top view. Mechanical people, they were drawing from their own end. Architecture people, they were doing their own work. At the site itself, they will know, oh, these elements are clashing with each other. And they used to cut those elements and reroute them. And it was a laborious process. Lot of wastages were there. Time consuming, labor waste, time waste, money waste. At the end of the day, financial things are what matters. Earlier, the construction field was having very less number of the profit margin was very less, but nowadays the profit margin has drastically increased because of these kind of softwares and technologies. Okay, and we can also see the cost estimation. We can calculate the cost of each and every element within that building. For example, in a building there might be thousands of switches, sockets, lights, air terminals, diffusers, sprinklers. How will they know how much cost it will incur? You can prepare a schedule. Within that you can add a cost of each element and you will get the total final cost of that particular category. Okay, cost estimation can be done using BIM. Collaboration, see, all these mechanical, electrical, plumbing, architecture, structure, interiors, landscape, all these services cannot be handled just by one person. There will be different teams for these different disciplines. Okay, so the BIM allows you to collaborate with them. At the same time, you can contact them and you can give them the like if you want to move a duct or pipe somewhere, you can directly call that particular person and you can show them, this is the pipe, this is the idea of that particular pipe, I want you to move this to the right side. He will, there itself he will move it. It takes matter of like 5 seconds to move a pipe or duct here and there. Got it? So collaboration in the sense we can collaborate among all the disciplines in real time. Okay, this can be done by using BIM. You might have seen when you open a same file twice, what does the error shows? It shows that you are opening read-only file. One drawing or model or something can be opened by only one person, right? Be it a CAD drawing, be it a PDF, be it a Excel, whatever it is. Only one person can access that particular file at one particular time. But BIM allows you to create a central file, same file, hundreds of people can access. There is a concept called a central file, same file. See, you might, like many of you know AutoCAD. In each drawing, only one person can work at a time. Yes or no? Similar, but in Revit, no. But in BIM, what you can do, you can collaborate with all the discipline people in real time. In the same model, everyone can do their own services. They can route, they can model their services. Okay, so this BIM allows you to improve the collaboration. Visualization. Before the construction starts, you can visually see your building in 3D. Not only from top, from 2D. You can also view that building in 3D. You can create some walkthrough videos and all to make the client understand how your building will look. Okay. Then we have efficiency. Obviously, efficiency increases drastically by using latest technologies and all. The wastages can be limited. The design changes can be easily managed. There are so many things, guys. Okay. So these are the reasons why we can use BIM. Now let us focus on MEP. What is MEP? This is the nervous system of your building. This is how your building is operating, functioning properly. All your washrooms are functioning properly. From like, you just imagine Burj Khalifa, there are thousands of washrooms maybe in that building. How, from where that waste is getting collected, where are the pipes running, where is it getting collected? Right? It is so huge. How are you supplying the air? How are you supplying the ventilated air, conditioned air? How? Because of these MEP services only. See, these are your MEP services. These are the ducts. These are the drainage pipes, sanitary pipes from your washrooms, kitchen and all. Okay. These are your maybe chilled water pipes. Understood? This is how your services will be. The services will be jam-packed. The red pipes which you are seeing here, no? These are your fire pipes. These are your chilled water pipes. Hot water, cold water, you have cable trays running here. There are so many services. See, this is your false ceiling. Above that, all your services will be running. These are your air terminals through which the air will come out, the conditioned air. There are so many services, guys, which we can model using Revit. These many services without any model, if you directly go to site and start doing it, there will be fights. They will fight. I want this space. I want this space. They will be fighting with each other. Understood? So this BIM allows you to have better visualization for all your services. Building doesn't mean only about architecture and structure. It also has MEP services, mechanical, electrical, and plumbing services. And the path of routing it, no, that is what we do in Revit. The designers will give us the markups and we will copy those within our Revit. Why do we do that? In order to understand, if I route this The designer has shown a line here. But what if it is clashing with this duct or with this pipe? Clashing in the sense it is flushing with each other. How will you know? Only if you create it in 3D, you will understand, oh yes, it is clashing with these services. Okay. So there are so many things which you can do in Revit. There is also a concept called as clash detection. Okay, detection. See, this is what I was talking about. The designer will not know where our ducts are clashing with with other services, because he will be doing everything from the top view. He don't know in real time how much, like what exactly the services are running, what are the elevations they are running into. Only after modeling those services within Revit, we will understand, yes, these services are clashing. And then we can talk to those concerned people, asking them to move this duct or maybe this pipe or maybe fire. See, here the fire pipes are completely flushing within the duct. See, just imagine if it was happening in site directly. Let us assume fire person came and he routed his pipes first day. Second day, the HVAC person came, this duct person, mechanical person. He wanted to route this duct at site. I'm talking about site real-time construction. He started routing from here, but then he realized that fire pipe is clashing. Now what shall we do? He cannot go right, he cannot go left. Left also there is a fire pipe, right? There is another duct. What will he do? He will call that fire person, and that firefighting person, he will say, hey boss, I am busy with another project, I will be back after 15 days. So the construction will stop there for 15 days. Whose loss is this then? Right? So to limit it, like to mitigate these losses only, this 3D visualization came into picture. Necessity is the mother of invention, right? There was necessity of a 3D software. That is why Revit came into picture. Understood? There will be thousands of clashes which the designer might have not noticed, and they were handling that at site directly. But it was an elaborate process, lot of wastages, lot of time. It takes time. Not everyone will be eagerly waiting for supporting you. They will be busy with their own work. They have to come, they have to cut. And even if that fire person comes, no, he has to cut this pipe, he has to cut here also, he has to then weld a new pipe and start routing from this side. How that the part which he cut, no, that is completely waste. This is the reason why Revit and MEP, this BIM came into picture. Okay. I will show you some samples of case studies which I have prepared in order to understand it better. See, this is Airport Terminal 2 project, Bangalore Airport Terminal 2 project. Okay, so this was the first project L&T took by using BIM. It was norm from the government that you should use BIM only for this project, or else you are not getting this tender. Then he hired, that L&T hired so many companies. It took like thousands of people were working for more than 6-7 years. Even I have worked on that project, Bangalore Terminal 2 project. Okay, so by using this BIM, even L&T accepted that they saved 30% of time. 35% of the time they saved because of this BIM. Okay, in many countries, BIM is mandatory. Many countries, BIM is mandatory. We are now, like, the BIM is now booming. Revit is booming. The construction is like at the world, like top. Everyone is constructing the Middle East, US, UK. There are so many vast structures being constructed, and without BIM, they cannot do it. 100% they cannot do it. It will be very difficult. Lot of wastages, lot of issues will happen. Okay, I'll not read all of these case studies. I'll just show you. See, these are the services. See, if there was no 3D, you just imagine how many clashes would have been there. This is just one plant room. Okay, one room. How many services are there? You just imagine. And these pipes are so huge that you can walk through these pipes. These are the services within one room. These are the services within one room. Same here. This is the roof where your chillers, your AHUs, everything will be placed. See how clumsy these things are. We cannot trust all of these for only with the construction people. They will not know the logic. They will know the process, but they don't know the logic. And they will not be concerned about saving your money. Why will they save? They are here just to work, and they will do on their own thoughts. They do it on their own plan, and they will finish the construction. Understood? See the services. You just imagine without 3D, how can these services be populated at site? These are just some examples. Then we worked on a WAPTech project. When this project came to us, the client was asking to create a 3D. He didn't know, like many of the contractors don't know what BIM is, what Revit is, what is a 3D model. They asked us to prepare this model within 20 days. You know how long it took? It is just a 10,000 square meter project. It was not a huge building or something. It was a small building itself, but you know how they were expecting in 20 days. It took us around 9 months. You know why? The modeling was completed within first week itself. We kind of completely modeled everything. Then the issues started appearing. They were concerned. There were so many issues that the government was not agreeing for their design. Then that is the reason it took us around 9 months to just finalize the design and create a 3D model of it. Now the construction will not be like, it won't take much time. When all drawings are available, the model is out of these model, we will generate the drawings. Okay, so now the construction will run smoothly. If this was not happening, all those issues were happening at site, and the construction would have been halted for many months, up to until the NOC is generated by the government. NOC is approved by the government. And who will bear those losses? What will the laborers do? What will be the person who is investing will do? How much money will he invest on this, right? So there are so many things which we can mitigate using BIM. See, this is the skeleton of that building, structural aspects. Many of these are structural aspects. These are MEP aspects of that building. This is how the modeling will go. We have to do everything in detail. Then we have to generate the sheets, and those sheets will be taken to site for the construction. They didn't know these many issues will happen. You just imagine 20 days to 8 months, 9 months. It is a big time frame. There were some cranes also in that project. We can model everything. See, these are the things which I have modeled in that project. These are the sheets generated from those models. See, HVAC drawing, how clean it is, how easily we can understand this drawing at site, isn't it? Then ITC, very stringent client. They need information of each and every element, even the screw, nut, bolt, everything they want. It was, see, they saved 45% of overall cost by using BIM. ITC building, Hyderabad. These are some snaps of that particular building. So this is a quick, I had prepared a case study. I just wanted to show you. So within 30 minutes, I can just give you the overview of what BIM is, what MEP is. If you join the sessions, you will definitely learn a lot. Okay. Then future of construction is obviously BIM, because BIM is mandatory in so many countries. Now, India is, like many countries, are taking projects of those countries, Middle East, US, UK, and all. We are taking projects from there, and we are doing those projects here. At the same time, India is also, like many countries are moving towards BIM, because initial cost will be more. I do agree that initial cost is where the license itself will cost you somewhere around 1.5 lakh rupees to 2 lakh rupees, Indian rupees I'm talking about. Initial cost is obviously high, but over the long term, if you see, BIM will save your money, save your time, save the waste, mitigate the wastages. This will obviously increase your profit margin, the construction margin. And I will tell you guys, I know you people are not contractors and all, but why I am telling you this is, BIM is now booming. BIM is now booming in the sense it is at top now. Everyone wants BIM. Everyone is talking about BIM. You are not in that field. Maybe you have not heard about it. Everyone has heard about IT, right? Layoffs, this and all. But BIM is also booming because of so many advantages of using BIMs. Okay. So in this, you definitely have better career opportunities, but you have to give your heart and mind to learn these softwares, and you have to understand the basics of construction. Then only you can achieve something. And it takes a lot of effort. It is not, as our colleague already told. See, remember this, BIM or any software is, whatever softwares you're using within BIM, no, they're not rocket science, but they're not so easy that you can simply just attend one session and you can learn, or you watch YouTube video and you can learn. No, you can never learn that. You have to physically work on a project while being taught. Okay, so this is the overview of what BIM is and how we do the MEP services within BIM. If you have any questions, please do ask. I have
Thank you,
question.
Faraz, sir. Yeah, go ahead.
I have got some questions here. Let me first read those. Sir, I have one question. This course is enough for doing the BIM engineer job. Otherwise, we need to learn some more softwares. Yes, very good question, Anand. See, BIM is a process. There is no tool. There is no classes only limited to BIM. Okay, BIM is a basic concept. Revit is a tool. Similarly, there are some other tools. If you are learning Revit, you should also know AutoCAD and Navisworks. These are the basic things which everyone is asking. Only if you know Revit, it is difficult these days. Like 2, 3 years or 5 years before, only the person who knows Revit was enough. But now you should also know basics of Navis and basics of AutoCAD at least. Basics in the sense, Navisworks is also very necessary. In Navisworks, we can do simulation, we can do the clash detection. See, all these aspects are within Revit also, but they are not like up to that mark. As our colleague already told, no, it is BIM itself has Revit itself has so many options, but they are not up to that mark. So what do? We export our model to different versions, NWC, Navisworks versions and all. In that, we will do the proper clash detection, simulation videos and all we do create over there. So you need to know, note down this: Revit, basics of AutoCAD and basics of Navisworks. These three. Revit, you should be you should be master in Revit, because that is your main modeling software. Okay. Have I answered your question, Anand? Good. Any others? Anyone else have any other question or something? Feel free to ask your questions.
Switch off stop your screen share, sir.
Sorry, Sanjeev.
Yes, sir. Can we finish this workshop, sir?
Yes. If anyone has questions, we can continue, or else we can conclude for the day.
Anyone have any
Sir,
questions?
hello.
Yes,
Hello.
Anand.
So what are we learning this all process? We should be pay for that software. Anything pay for the software process, this downloading it.
Your voice was breaking, but I
Hello.
understood a part of your question. Let me answer that. You are asking how can we get that software? Are we supposed to pay? The thing is, guys, yes, you have definitely the license version is you have to pay. But if you are a learner, if you are a student, you will get a student version, free student version. And up to 2022 version, Revit 22 version, you can download it and you can use the complete version of that software for 1 month. 1 month there will be a trial period up to Revit version 2022. From 2023 they removed the trial version also. You can there are so many softwares through which you can crack the software also, but actually the software is very costly. You can get that from Get Into PC, you can get it from Autodesk itself. And if you sign in as a student, you will get that free version for a year. Up to 1 year you will get that free version of that software.
No. My student ID card is expired already. The 2024 is completed now. 2025 now. They will not accept it. Then how can?
Then you have to crack it.
we-
You have to go for a crack version that is easily available in getintopc.com.
PC that.
Yes,
All softwares are
getintopc.com.
available, sir.
Exactly. You will get n number of softwares there. No matter what software you want, you will get it there. And there will be also a video how to install that software and how to crack that software. You can download that video also, and you can just explore whatever you want. But for Revit, no.
Pay for the audit.
Yes, it will be very costly at the beginning stage. Once you are within you are doing this job, the company itself will provide you the license and all.
Without any paying, we learn all the software with no problem. No?
Sorry.
Without pay, without without pay, we learn all the software or maybe difficult. That's why I think.
I still didn't understand. Your voice is breaking.
Okay.
Can you write down the question?
Then anyone else have a question?
No, ma'am.
Okay, then let us conclude. Right, Roshni?
Yeah. Thank you so much, sir. Thank you for your time and your support. Now our team will go ahead and discuss more into details about the coursework. Thank you.
Sure. Welcome. No problem. Thank you, guys. Thank you so much for your time.
Okay, I think we can end this session. As we wrap up today's session, I hope you have a clear understanding of BIM and its significance. And also, I want to mention about tomorrow's topic. Tomorrow, we will be covering Bluebeam, Centro 4D, Primavera P6, and Navis work. Thank you, everyone, for joining us today and being so patient and listening to the BIM and Revit. We'll meet again tomorrow. Thank you so much.